In our last topic for this unit, we are finally going to do our first geometry proofs. Now, when you tell your parents what you're working on in geometry, again, some people may cringe when they hear the word proof, but we've already done proofs. We just haven't written them out yet. A proof is just explaining your steps so somebody else can see how you got to your final conclusion, to your final idea. And so all we need to do is formalize how we're writing these down a little bit. So we're actually going to start with a practice problem from a couple lessons ago where we are given parallel lines and we have to solve for x. So we've already done those problems. Let's just look at another way to write these out. Okay, just as, to help alleviate any stress about doing proofs, you are never going to be asked to do a proof totally on your own. You will always be given a word bank. You will always have, if you don't have a word bank completely set out, you'll have like missing pieces of the proof, and you'll have like drop downs to fill in what's supposed to go in that spot. But you'll always have something to help you out on that proof. You will never have to come up with the reasons just randomly on your own. And so the practice that you're going to do today will be exactly that. You're going to be given all of your statements and your reasons, and you just have to figure out the order. On your lesson check, you're only doing 2 proofs, one of which I'm asking you to put your reasons in order, and one of them just has a few random pieces missing that you have a word bank to use to fill out. So let's check out this problem. Again, our first problem, this is really just a problem like what we've done in like lesson 3C, I believe. So let's check it out. So our first example, we are given that lines M and N are parallel. RSU, so angle RSU, is equal to 8x plus 4, and angle STV is equal to 9x minus 11. We are trying to prove that x equals 15. So in other words, we're just solving this out and finding x. And if you look at the proof, even though this is a longer proof with 8 steps, you'll notice every single step is already written out for us. We just have to explain why each step is true. And notice too, before I did anything, I actually highlighted my angles. So if you're given information on a proof, it's always a good idea, mark it up on your proof, mark your angles congruent that they give you, do something to organize your info. That's why you have a diagram in the first place. Okay, so first thing that we're starting with, lines M and N are parallel. Well, we already had that listed in the problem. They gave us that information. So our reason for that is actually just given. Any info that they started you out on, your reason can be given, or your reason is given. And our next statement, RSU equals 8x plus 4 and STV equals 9x minus 11. Again, they gave us that information. Our reason is given. You can absolutely repeat reasons if you're reusing the same idea, or if you're using the same type of logic. Okay, so our next step says STV is congruent to RSU. So let's think about that. We were given that lines M and M are parallel. So let's actually mark that. So again, one of the ways we marked that was an extra set of triangles or an extra set of arrows. So if those lines are parallel, then how do my outlined angles, what are they supposed to compare to? Well, wait a second. That's a special pair of angles. Those are corresponding angles. So if my lines are parallel, then I know my corresponding angles are supposed to be congruent. That's a rule. We've used that. So that's what I'm going to write down for my reason. Corresponding angles are congruent. And again, abbreviating a little bit just so it doesn't take me so long to write stuff out. Okay, so then my next statement says 9x minus 11 equals 8x plus 4. So, well, those are just the measures they gave us for the angle. So it looks like we just kind of rewrote our statements out based on what we knew about our angles. Whenever we're going to just rewrite or substitute in something that we know is equal, we call that step substitution. And I'm going to put in quotes rewrite. So you won't see this as rewrite when you see possible statements and reasons. You'll see substitution as a reason, but anytime you're rewriting something, that is your substitution rule. Okay, so our next step, it looks like, well, if we were just doing this problem out, we'd have to start solving it out. And one of the things we could do is start moving our constants. So it looks like they added in this -8 on both sides. So they're trying to combine their like terms and move their x's around. So if they subtracted 8x, this is just subtraction. That's just the math that we did. And then our next step, well, if we do 9x minus 8x, we end up with an x. If we do 8x minus 8x on the right-hand side, the x's go away. So this was just kind of rewriting our simplified work. Rewrite step means substitution. Alrighty, then our next step would be, again, isolate the x. So we would have to add an 11 to both sides. So our rule is just addition, because that's all we're doing. And then our last step, if we're just rewriting what we've got when we do 4 plus 11 on the right-hand side, or -11 plus 11 on the left, rewrite step, substitution. Again, same problem that we've done earlier in this unit, it's just a much more formal way of writing it out. So anytime we just rewrite something, we're going to say substitution. Anytime we do some math, just say what math you did. And then if you have to use one of the rules or definitions that we had, you can say your definition or just write out the rule. Okay, let's look at example 2. So much shorter proof on this one. We are given that angles 2 and 3 are supplementary, and we're trying to prove that angle 4 and angle 6 are congruent. Okay, so I don't really have a way to mark supplementary on my diagram, so that's okay. But if they gave that to us, then our first reason should be just given. Okay. So, well, let's look at where angles 2 and 3 actually are. So angle 2 is here, and angle 3 is here. I'm going to mark one with a single arc and one with a double arc, just so I can see, looking at the diagram, that these are different angles. But looking at where they are, these guys are both on the right-hand side of that kind of piece of the triangle, and they're in between two lines CD and AB. So if we go all the way back to the beginning of our unit, these guys are actually in not corresponding, but consecutive interior angle spots. And that's just because that's where those angles are. That's how we defined those angles. So we're just going to say definition of consecutive interior. And again, I can't really say anything yet, just knowing that they're consecutive interior. But now when I put these two things together, I have angles that are consecutive interior angles. We were given that they are supplementary. So if consecutive interior angles are supplementary, then that means that our lines are parallel. That's kind of our converse that we looked at a couple lessons ago. So converse of consecutive interior angles. And we could write this out in length and say, if consecutive interior angles are supplementary, then the lines that intersect their transversal are parallel. But you don't have that kind of room. So just simplify, abbreviate a little bit. So now we know that lines AB and CD are parallel. So let me go ahead and mark those on my diagram. And so then our final step, the thing that we're trying to prove, is that 4 is congruent to 6. And so looking at where these are in the diagram, highlighting them in red, if I know that I've got parallel lines, which I'm going to do let's do blue. So there's my parallel lines with my transversal, and I've got my red angles. Well, do those make a special pair now? Well, yeah, those are in the corresponding spots. And if I already know that my lines are parallel, then that means my corresponding angles also need to be congruent. So that's what I can use as my rule. So if lines are parallel, then corresponding angles are congruent. Alrighty, let's try another one. Again, if you need to, pause the video, let this kind of sink in, rewatch this section if you need to, and then come back and look at proof 3. Alrighty, proof 3. So this one's missing a few more pieces of info, but again, we're still given something to help out. So we are given 2 things. We are given that angle 1 and angle 2 are congruent. So let's go ahead and mark those on the diagram. We are also told, I'm going to put this in a different color, that angle 1 and angle 3 are congruent. So let's mark those as well. So those are in my red. Okay, so if that's what I was given in the problem, then that's what I should probably start with. So beginning of my problem, the first step says angle 1 is congruent to angle 2 that was given. Okay, excellent. So we have a second piece of that's given, so let's write that in. So angle 1 is also congruent to angle 3, and that was just given to us. Okay, so before I really figure out what's going on in my proof, I know eventually if I'm trying to prove that AB is parallel to DC, that should be my very last statement. So I can go ahead and fill that in just so I know where I'm going with this proof. So line AB is parallel to DC, and wait a second, we now only have 2 things we really need to fill in on this proof. So let's think about this. So we have angle 1 congruent to angle 2. We have angle 1 also congruent to angle 3, so wait a second. Could we do any kind of rearranging with these expressions? Let's see. If angle 1 is showing up twice here, and he has to be congruent to itself, then what about angle 2 and angle 3? Well, if angle 1 matches up on one side of the equation, well, angle 2 and angle 3 should match up on the other, and we could basically just rewrite our expression. Wait a second, rewrite? What's our reason? Anytime we can say rewriting our order, substitution. And so now we have in our proof, step 3, angle 2 and angle 3 are congruent to each other. So that means if angle 2 and angle 3 are congruent to each other, do they make a special pair? They make alternate interior angles. So this is actually our converse. So if alternate interior angles are congruent, then the lines have to be parallel. So if alternate interior are congruent, lines are parallel. Again, abbreviating a little bit, but there's nothing wrong with doing that. In the proofs that you're going to practice with, it will have your statement completely written out for you. But if you're writing things out, you're more than welcome to kind of simplify things a little bit. Okay, one more proof. Oops, let's go back to my select tool. There we go. So proof number 4, again, fairly short, only 4 steps. But this one's completely blank. So first thing that I know is I'm given that L is perpendicular, and don't forget that's what that symbol means, perpendicular. Again, you've probably seen that before, but just in case. So L and T are perpendicular, M and T are perpendicular. Now you can do problems a few different ways, and if you want to, you can actually list out multiple givens in the same step. And I'm not sure how many steps this proof is really supposed to take, so I'm going to go ahead and write both of those in the same step. So L is perpendicular to T, and M is perpendicular to T. And it's okay to do that as long as you have the same reason, and those were both given, so I can put them together in the same step. Okay, so what do you know about perpendicular lines? Well, where they intersect, they make what kind of angle? They make a right angle. So we actually already have some angles labeled. If we have L and T are perpendicular, then what should the measure of angle 1 be? Well, he should be 90 degrees. So angle 1 equals 90 degrees. And the reason I figured that out was because my lines were perpendicular just from what I know about perpendicular lines. So if that's the case, if that's just, well, hey, that's what we know, that's a definition. So we're going to say definition of perpendicular lines. But wait a second, can I do the same thing with angle 2? Yeah, why not? I could have even put it in the same step if I wanted, but I'm going to go ahead and put it in the second one. So angle 2 is also 90 degrees. Same reason. So definition of perpendicular lines. Because if lines are perpendicular, they meet at a 90-degree angle. Okay, so that means we know that angle 1 is 90 degrees and angle 2 is 90 degrees. So wait a second, that means they're equal, doesn't it? So is that enough to prove that our lines are parallel? Well, yeah. And our last step is always supposed to be the thing we're proving. And our reason being, well, if I have two 90-degree angles, they're congruent to each other. So we could also use the idea that I mentioned in a previous video. If I have lines that are perpendicular to the same transversal, then those lines have to be parallel. So we could actually use a couple different rules here. I'm going to write that fancy one down just in case you see it in a future proof. But if lines are perpendicular to a transversal, how about I spell that correctly? Then they are parallel. And again, this isn't the only way we could have done this proof. We could have said also, any special angle pairs do you think are popping out at you? So I could have said, well, if angle 1 and angle 2 are congruent, and I would probably need to do an extra step, then my corresponding angles are congruent and therefore my lines are parallel. So just because I did the proof this way doesn't mean it's the only way to attack the problem. Just like algebra, you might do your steps in a slightly different order, but as long as you're using correct algebra, it's still a correct problem, or technically a correct algebraic proof. Alrighty, so your practice is a little different. I don't want you to be doing proofs and not knowing if you have them correct. So your practice is actually an interactive proof site where, again, you're going to do a few proofs and you can actually self-check on these proofs. So read the directions carefully that I have on the assignment. So I go step by step what all the symbols mean on the website. But again, if you run into any problems, if you're not sure how that website works, again, pop right back into Zoom and let me know what's going on. If needed, we can even go into a breakout room. You can do a screen share and we can figure out how to work that proof, or at least get you set up on how to use that site. Okay, as always, let me know if you have any questions. See you later.